This time I'd like to talk about capacitors. Now, a capacitor back in the day used to be called a condenser. So if you see the term condenser instead of capacitor, you're just probably looking at something written before about 1960. After about 1960, most of the literature refers to them as capacitors. Okay, at the top up here, I have some a kind of dichotomy. By that I mean dividing into classifications for capacitors. So let's take a look at that first. Now this is just my way of dividing up capacitors, and there are lots of different ways you can do it. We'll see later. Could do it by the way the leads are attached, the basic technology that they're built with, and so on. And the technologies have changed a lot over the years. But generally, you can divide capacitors into fixed and variable. Now, variable capacitors usually are either for tuning or trimming. Now, sometimes what you are trimming is the tuning, so sometimes you have a larger tuning capacitor and a smaller trimming capacitor. Let me show you an example of one of those. This is a tuning capacitor, and if there were little screws down here, these would be the trimming capacitors. Generally, a trimmer capacitor you adjust with a screwdriver, whereas a tuning capacitor you tune with a knob. So you may notice that as I turn the tuning knob on this radio, this capacitor meshes. Now, this particular capacitor is a typical tuning capacitor. You'll notice that it consists of a set of plates at the bottom. Those are usually called the stator for stationary, and the rotor, which is a set of plates that rotate. You can generally tell a superheterodyne radio compared to a TRF because it will have a couple of stages, and they will be different sizes. You may be able to tell this capacitor is actually slightly more capacity than this one. And when we get to talking about mixers and converters and all that, we'll explain why those are slightly different sizes. But for now, all you really need to see is that it's a set of plates that are fixed and a set of plates that rotate. You make electrical connection to this set of plates through one contact and to this set of plates through another, and these do not touch each other electrically. Getting back to our classification, this is a very tiny trimmer capacitor. I think it's a 7 to 40 picofarad, and once again, don't need to worry about the terminology picofarad, except to say that capacitors are generally rated in farads, named from Michael Faraday. However, often they're usually only in microfarads, which just basically is a millionth of a farad. The definition of a farad is a pretty good sized capacitor, obviously. Very few circuits use farads of capacity. Most of them use microfarads or a smaller quantity. Generally the smallest quantity used to be called microfarad, which means a millionth of a farad. Today that's called a picofarad. Okay, the other type of capacitor besides variable is a fixed capacitor. Now these are supposed to remain at whatever the rated capacity is for the life of the capacitor. And they generally consist of wet types and dry types. Now by wet type here, there used to be an old type that was actually like a battery. In fact, the only difference, they were called cell condensers, and the only difference between a cell condenser and a battery or an electrolytic cell is generally a cell that's designed to produce electricity uses two dissimilar electrodes, whereas a device that was designed to store electricity, which is what a capacitor does, had electrodes of the same type, generally a metal. And then also there is a can type, and by can type what I mean is that they are put inside generally a metal can like this, and they are sealed up. Now, there is the inside, there are plates that have a wet electrolyte, and those plates are generally soaked in an electrolyte solution. And I'm not going to get into the actual manufacture of these things, but if you are interested, I did a video on vintage electrolytics. They used to be made in a way that is different from the way they're made today. And except for that, that's all I'm going to say on that subject. Over here to the right, you see some fixed capacitors from the period, and, well, zoom out just a little bit further so you can see them a little better. Okay, now, this, for example, is a very high voltage capacitor. In fact, if I remember right, it's a 1600 volt. Yeah, it's a 0.05 microfarad. It may not be able to read that very well, but let me see if I can get it where you can. Well, there, 0.05, 1600 volt. So the reason for its size is because of its voltage rating. Obviously, it doesn't have as much capacity as some of these others. A newer type looks like this. And sometimes these can have as high a voltage rating as these do, simply because the technology has improved. This is another kind that is a capacitor. Sometimes you find these made of mica, that is with a mica insulator, and we'll talk about that in just a second. But most of the time, these that you find in old radios actually have a paper center or a dielectric. Now, the reason that's important is generally paper deteriorates because of the acids used in the paper making process. So over years, these kind of capacitors do decay. Mica does not tend to decay. In some earlier videos, I once made the reference to the fact that an old-time radio guy once told me that if it grows on the mountain, it'll fail. If it's part of the mountain, it won't. So, of course, anything made from stone like mica generally tends to last, whereas stuff made from trees tends to deteriorate. Down here are 4 electrolytic capacitors, and I did this deliberately to show you that you can't tell the capacity of the capacitor from its size. This is a 16 microfarad, this is an 8 microfarad, and this is a 20 microfarad. So the smallest one has the highest capacity of these 3. You also can't tell a capacitor by its color. It can have all sorts of different colors. Different manufacturers used different techniques. These are a couple of modern capacitors. This is a 50 microfarad, 450 volt. This is a 47 microfarad, 450 volt. So you would think that this would be the better capacitor, but actually this one is. This one is rated up to 105 degrees centigrade, whereas this one is only rated to 85. And you may notice one other thing about these two. This one has the leads coming out of the ends. There's one over here that's bent back, and then one here. This one, on the other hand, has both leads on this side. These are called axial lead, and these are called radial lead. Be careful when you're ordering replacement capacitors that you get what you're looking for. These tend to be very readily available because they make them in the millions. These tend to be a specialty purchase, so if you're looking for an axial lead capacitor, you better make sure that's what you're buying. If you buy from places like Antique Electronic Supply or which is also called Tubes and More, or any of the other specialty shops that sell to old-time radio repairmen and restorers, you can find these fairly easily there. They're a little more expensive, but nonetheless they're available. Okay, over here are three types of capacitors. The one at the top is a wax paper capacitor, and you'll notice there's a little black band. That's generally called the outside foil, and that should be connected to the ground end of the circuit. Mr. Carlson talks a lot more about this, so I won't go any further. Similarly, this one is a different one. This has a hard case. By the way, these you can tell because if you touch them with your fingernail, you'll see that they just have a wax outer coating, and under that is paper. So you can literally crush those in your fingers if you push hard enough. This, on the other hand, has a plastic coating, but don't be fooled. That doesn't mean that this is necessarily a plastic capacitor. It may be a paper capacitor with a plastic covering. And then down below is a more modern style. Not that modern. Actually, this is a style from the 60s. So let's go back up here and talk about the kinds of electrolytics and then why we have to have these different kinds. Generally, fixed dry capacitors. The old style was to make them out of paper with wax impregnation and also with mica. Today, most capacitors, fixed dry capacitors, are made with plastic dielectric and usually a plastic coating. That can be Teflon or a polyethylene or different polystyrene. There's a bunch of different plastics. We're not going to get into that itself. In addition to this rotary tuning capacitor that we looked at earlier, you can also find some that are compression type, that where you turn a screw to squeeze or release the tension on a little insulator. This is a same basic type. They also have rotating plate capacitors like this, where basically the plates rotate just like this, but they're much closer together with little plastic spacers in between. So instead of spacing the plates apart like this, they're actually squeezed together with a very fine piece of plastic in between, and then as you turn the screw, it compresses the plates together. Now, paper capacitors generally are built like this, and you'll see them in different types. Generally, the tubular paper capacitor is made by putting insulating paper and foil. A layer of foil, then a layer of insulating paper, then another layer of foil, and so on. And then rolling all that up with a lead attached to each end, generally, and it tends to produce this kind of capacitor that looks like this, once again with one end generally designated as the outside foil. In other words, it is the foil plate that is closest to the outside edge of the capacitor. They also make bathtub capacitors, and by bathtub they don't mean wet. They just mean they're in a plastic case, or sometimes it's phenolic. You see these a lot in old Philco radios, and the filler is often a fairly high temperature wax, and to open them up and to replace the capacitors inside, you have to melt the wax out. If you look at some of my restoration videos, you'll see this. There's also hundreds of others of people on the internet that have done the same thing. So generally, tubular capacitors come with working voltages up to around 1,000 volts and a range of up to about 2 microfarads in size. There also are metallized paper capacitors that run in about the same range, and those were often metallized to provide better sealing. Now, you can also use mica as an insulator, silvered mica, and when we talk about IF cans, we need to pay special attention to the silvered mica because it has a particular tendency to decay that is often called silver mica disease. You can also make capacitors out of ceramics, and often disc capacitors that you find are ceramic. We're not going to talk about those here because you don't tend to find those in the old radios, generally only in the radios after the war. This is a rolled ceramic. Once again, like I say, you generally find these in radios from the 50s and later. Now, going back for a second to electrolytics, generally a wet type electrolytic has actually a liquid electrolyte, whereas the dry type electrolytic has a wet roll of some kind of absorbent material that is impregnated with the electrolyte. If you ever open up one of these electrolytic capacitors, whether the so-called dry type or the wet type, be very careful that you do it in a place where you don't mind if it spills, and wear gloves because these electrolytes can be caustic. Now let's close by just talking a little bit about capacitor theory. A capacitor is basically two metal plates, or two conductors I should say, separated by an insulator. The capacity depends on three things: the size of the plate, the spacing of the plates. So the bigger the plate, the higher the capacity. The smaller the spacing, the higher the capacity. And finally, the insulator in the middle, which is often called the dielectric. And different materials make different capacities. So if you use a material with a high dielectric component or dielectric constant like Michael-X, notice it has an 8, whereas air is just a 1. So a Michael-X capacitor with the same size plates and the same spacing will have 8 times as much capacity as an air dielectric of the same size. Finally, the breakdown of a capacitor is rated in volts, and the material that is used determines what that breakdown voltage is. Notice that the beeswaxed paper has a very high dielectric strength. Now dielectric strength is not the same as dielectric constant. This is how much voltage they will take. Notice mica is the highest of them all. A very thin sheet of mica will resist a lot of voltage. But as you will discover when you begin to look at some of these old radios, paper, as I said earlier, deteriorates. So even though this is the rating when the capacitor is made, it may wind up being 800 volts or maybe only 80 volts by the time you get the radio, especially if the radio is 60 or 70 years old. So once again, I hope this has been useful material, and I hope that you find it helpful as we go forward. If it seems a little esoteric at this point, don't worry too much about that. You may have noticed I don't talk about testing capacitors like I did with resistors. The reason is I want to defer that for a little while. My view is that if you're trying to focus on the biggest bang for the buck, you don't buy a capacitor tester. There are some you can build, and I'll talk about that when we get there, but you can generally test capacitors in the circuit with the voltmeter. However, in these old radios, in general, it's best, because the paper breaks down, to replace all the old paper capacitors. Once again, I said we'll get to that when we get there, but for right now, I hope this has given you an overview of the wide variety of things in an old radio that are called capacitors. Look forward to the next video. I hope will be upcoming very soon, and have a nice day.